Hi and welcome back to my channel. Can you solve this IGCSE problem? Can you find the area labelled R? That is the area made by two overlapping circles, one of radius 5, one of radius 4, and the line segments going from the centres of the circles to the points of intersection of those two circles, A and B, as you can see on the diagram. Now, if you want to solve this problem yourself, feel free to put your solution down in the comments below. I'm going to show you my solution in a second, so pause the video now if you want to do it yourself. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I would do is to split the area R into two separate sections by making a chord from A to B. Those sections I'm going to label R1 and R2. Now obviously we know R1 add R2 is going to equal the total area we need R. But just for reference, we're going to split them up and to make things easier in terms of labelling. The next thing I want to do is just to consider one of these triangles and then consider one of these areas. So I'm going to think about, first of all, R2. So I can work that out by doing the area of the minor sector AOB. So that's the sector, so that is going to include the triangle and R2, and then subtracting the triangle from that. So first of all, what I need to work out is the area of the minor sector. It's the minor sector because it's a small one. It's the one with the 50 degrees and not the one with the 310 degrees on the outside. Okay, so the area of that sector is going to be theta, the angle, over 360 times by pi r squared, because we are working out area, so we want a fraction of the full area of the circle. So 50 over 360 times pi times by 5 squared. That gives 125 over 36 pi. We then need to work out the area of the triangle. To do that, I'm going to use a half AB sine C, where A and B are two sides of your triangle and C is the angle in between those two sides. That gives an answer of 9.575 dot dot dot. And now I've put dot 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 because that is a decimal that continues. However, I can't write down all the decimal places all the time for all of them. I mean, I could do, but it'd be a lot of numbers. And actually, what I'm going to do is store that number on my calculator. But the dot 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 is there to signify that I am not truncating or rounding this number, because I don't want to end up with a rounding error at the end in my answer. From there, I'm going to subtract those two answers to give me R2, which is 1.332 dot dot dot. Now, if we go back to the original problem, we have got R2. We now need to find R1, and you can see we're going to use a very similar method for that. There's just one problem in that we don't have an angle between AP and PB in the same way we had the 50 degrees. So what we need to do is figure out a way to work that angle out. One way you can do this is by noticing that there is a line of symmetry. There has to be a line of symmetry from O to P, and so that will split the 50 degrees into 25 degrees, and then we can isolate one of those, the top side or the bottom side, to give us a triangle. Now, it's not necessarily a right angle triangle, so we can't use right angle trig, but we can use, obviously, non-right angle trig. So I've got an angle opposite a side, and I've also got the angle I want to work out. The one at P, so APO, is opposite the 5. So what I can do is I can use the sine rule. So sine 25 over the opposite side is equal to sine of another angle in the triangle over the opposite side. So sine APO over the opposite side, which is 5. I then start to rearrange that by timesing both sides by 5. We want to isolate the angle APO. I'm then going to inverse sine both sides of this equation to give me sine minus 1 of 5 sine 25 over 4 is equal to the angle APO. So that gives me an answer of 31.888 dot 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 degrees. So if we put that in, we then go back to the original quadrilateral. We are going to have to double the 31.888, giving us 63.7. We are then at the point very similar to earlier, well, identical, just different numbers, so we can follow the same procedure. We are going to work out the area of the minor sector, APB, and take away the area of the triangle. So the area of the sector is going to be 63.7 dot 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 over 360 times pi times 4 squared is 8.905 dot dot dot. The area of the triangle is a half AB sine C, so a half times 4 times 4 times sine 63.7 dot dot dot. Make sure you don't round or truncate it, because again we will end up with a rounding error. We'll be slightly off the answer if we do that. That gives us an answer of 7.176. I've stored these answers on my calculator to make sure that I'm including all of the digits. Subtracting the two will give us 1.728. And at this point, going back to the original problem, we have got both of the values that we need. We've got R1 and R2. So all that is left is to add them together, giving us a final answer of 3.06 centimeters squared. Hopefully, if you attempted this problem yourself, you were able to get the answer. If you did it a different way, even slightly differently, let me know down in the comments below. And if you were able to do this yourself in the same way as well, similarly, let me know down in the comments below. All that's left to say is thank you so much for watching, and if you haven't already, please consider liking the video and subscribing to the channel. And there should be some more videos just up here, or a video that you can click on and watch if you want to. Thank you, like I say, so much for watching. I will see you next Monday at 5 PM for another problem solving video. Until then, bye-bye. Bye-bye. There we go. That way round. Bye-bye.